So there are n cities connected by some number of flights. You are given an array flights where flights of I is equal to from this to, and there is a price associated with that flight indicates that there is a flight from city this to this with the cost this. You are also given 3 integers source, destination and k. Return the cheapest price from source to destination with at most k stops. With at most k stops means I can directly go from source to destination, or I can take 1 stop, 2 stop, 3 stop, or at max k stops. So if there is no such route, return -1. Okay, essentially we are given a set of cities, and this will be, we want to go from source to destination by using at most k stops. Let's see. So we suppose we are at the source. So here, it is the destination. From source I want to go to destination with some prices for each. I can take at most k stops. I need to find the shortest price. Is it cheapest price from source destination with at most k stops? Okay. At most k stops I can take. So shortest path to reach this node, destination node, from the source node with at most k stops. Is it a directed graph or what? Yeah, it is a directed graph because so suppose here, suppose we are given some this edges also. So what's the distance to reach at the what's the price to reach at destination? If I take some path, I will have to, in that path I will have to take at least that intermediate number of nodes stops, right? So 1 stop here. In this path there will be 4 stops, but I cannot take that path. Because suppose k is 3, so I can take, so there might be some other path. So this might be cheapest, but since it requires 4 paths, 4 stops, this might be cheapest, but this requires 4 stops, so that's why I don't choose it. So if 3 is good, so if there is a path from here to here directly, then maybe this path, may be better because it requires only 2 jumps. So from here, from the source, if I want to go to this node, so that will have number of stops also is 1 as well as the distance. So I need to keep both things are. So what's the distance to reach at this node, but as well as how many jumps I have taken. So So from here, so if I go to this node, so let's suppose from source node somehow I went to this intermediate node, okay, and I want to go to this destination node. So there might be some other paths in between. So if I know the distance, the cost to reach, the minimum cost to reach at this, the minimum price to reach at ith node to this node within k steps, or k, let's say j steps. What is this? Okay, so this intermediate node I, capital I, so in j steps, the minimum price to reach at this node in j steps. So what is this? Not j, at least j, or j. Yeah, let's say both will work, because I can always iterate from 0 to k and find the minimum. Because at most k. Okay, so if I somehow reach it here, then the question is the minimum cost to reach from ith node to the distance node, to the destination node, in, suppose for j steps I know the answer, so k minus j steps from this will be the source node. With Dijkstra, so minimum, so from source I can go to any other node in one step. Okay, what's the price? So if that is already calculated, then fine. So from source to the same node in 2 steps, what's the cost? So if I'm going from some intermediate node to its neighbor, let's say n1, n2, n3. So what's the cost to reach at n1 will be? The cost to reach at n1 will be cost is one factor, as well as the number of stops will be the answer. So number of stops is suppose j and cost is c to reach at this node. Then let's suppose p1, p2, p3, then here it will be p1 plus c. Since I have already taken a stop here, so it will be j plus 1, right? It will be p2 plus p3 plus c, j plus 1, is it? So in Dijkstra we always have this factor. Here we also have this factor. Directed cyclic graph. Okay, so if it is not possible, then what? Written -1. Okay. So can we solve it using Dijkstra? from source, let's start and go to all the neighbors of the source. Okay, so the source will have currently 0, cost is 0 and jump is 0. So from here, if it goes to here, that means one stop. So from source, it will have only 0 stop, right? It will directly go. So from source, it will update D1, let's say price, P1, P2, P3. So the costs will be P1 and jump is also 0. That means in 0 stoppage, I can, the minimum cost to reach at this node is P2. In 0 stoppage, the minimum cost to reach it here is 3. But if from here, if I go from here, so let's suppose it has this and it has P1 2, so it will be, so if that is not a source node, that means I'm coming to an intermediate node and from a non-source node, then the gap will be 1 plus gap will be, so it will be P12 is the cost plus previous cost P1 and the gap is previous gap plus 1, which is 0 plus 1, which is 1. So if it again goes back to this one, what happens? So that means, so to reach here I have taken one gap, I have taken one stop, which was this one. So from here, if I go to this node, so since it is a non-source node, so it is suppose P13. So this distance will be P13 and the total cost will be P13 plus from which node I am coming, which is P12 plus P. And what's the gap, what's the stops, since it is a non-source node, so 1 plus 1, which is 2. So this one, it will update this one. So I think for every node we would need to store this thing. So cost of I is it a matrix or something else? Okay, we are given a graph only. It can be, okay, we'll have to create the graph. So cost of so that means for every node I need to create a vector like this. So cost of node u in k steps, so it will be for this node in 2 steps. I think, yeah, it is somewhat dynamic programming also. Let's see if it can be solvable. I think I got this. Let's find cheapest price. Find the cheapest price. Cheapest price. It will return int only, so which will take number of flights and the number of cities are. What is this vector? Vector of integers is flights. Okay. Source, destination and k. Source, destination and k. FLIGHTS. To find cheapest price. What is an vector of flights? FLIGHTS. What was that? Okay, source, destination and k. Okay. And is the cities. Okay, you are given many flights. Let's create the graph. Adjacency graph. Is it required or it is already adjacency? Flights of 0. Iterate over that, we will get 3 things. Okay, I think not required. Adjacency not required. We have to have a vector of cost. That means cost to reach at city I within step k and cross k. So let's say currently cost is infinite and cross k, because in the last step I will reach n-1th city or the destination city, which at worst case will be n, and in k steps. Okay, in cross k, and we can say cost of source in 0 steps is 0. Cost to reach at source in 0 steps is 0. Why? Yeah, because I am standing at the source only. Cost to reach at source in 1 step. Exactly 1 step or at least 1 step. At least 1 step is 0. Cost is the minimum cost. Let's see. We'll see. So set will have a. What will set have? Set will have the pair. First is the distance to reach that, and second is the which city it is. Set will have the cost, but which one I will process first. So whichever is the minimum cost plus the cost, minimum cost plus what's the, so it is the distance, it is the cost, and it is the node. Will node work, or node as well as the k will also need? I think for a node we can have the same cost but different k, so it would need pair of okay. A set of pair of int to pair of intent. So int is my cost to reach at this node. To reach at this node in this many steps. Okay, so we can so cost is 0, source node, and in 0 steps. Let's apply Dijkstra. So while set is not empty, begin. the, let's erase this, and I'm starting at p dot first will be the distance to reach here, and p dot second dot first will be the node. Let's have that. So into u is nothing but p dot second dot first, and how many steps, it is nothing but p dot second. Okay, what's the distance to reach here? I know. Let's go through auto T over the flights. Let's iterate over the flights. So let's iterate over the flights, and for flight I have the destination node. So in V is the flight of, what is this order? So from to source, from to and price. Okay, we have to create the graph because it is the adjacent, it is the edge list only. So we will have to create the graph. Let's have that adjacency of n and to flight. You can say adjacency of flight of 0 is the source dot implies back. What? It will be a pair. So it will be the destination, it will be the weight. So it is flight of 1, and what is the weight? It is 2. So we'll have that adjacency matrix. Go through the, so let's go through the neighbor of this node, of the source node. We have the neighbor V. So okay, let's iterate. So we have the adjacency list, go through all the flights, create the graph. So from here to here with this weight, add an edge. So cost to reach and cross key, and set will have the pair of, it is the current cost and it is the node, and what's the steps, number of steps. So cost to reach source 0 0, st dot insert 0, source 0, 0 source 0. Obviously go here, I have the u at which node I am standing and how many steps I have, how many stops I have already taken. So from here I go to distance v, so I go to node v. So if the cost to reach at v in how many steps? Okay, steps will be required as well here. Okay, let's take the number of steps. So to reach here I have taken j steps. If I take one step, at least one step, So if I take one step and go to so if it is the source node, then there is no okay, can we simulate it with -1? How will you from source to direct node? It will be 1 only. So let's check if u is equal to source, then we can have that. Check. Otherwise, if it is an intermediate node, then from that I need to take one step. If I go to this from the intermediate node, if I go to here, so that means I've already taken one stop. So if it is not intermediate node, then what do I want to calculate? So from u to v in k steps. Okay, let's say I don't know how to. So if the cost, if I know the cost to reach at v in k steps is greater than the cost to reach at v, because from u only I'm coming. So k plus which is k minus 1, right? So cost to reach it, so from intermediate node, cost it will be v to k plus the price which is j. No, j is the jumps, and v dot first. So we can have v dot first. So and v dot second is the weight. V dot second. So no, think. So what happened? So I'm currently at this node. So while set is not empty, get the first node, erase that node, and take the node I'm standing, u, and what is p dot first? P dot first is nothing but the distance, cost of u comma j. So what do I know? So u comma j I know, right? So let's not write it like this. So from here, go to neighbor. Let's say it will be a pair neighbor. So auto neighbor over the adjacency of u, which is a pair. So mdr dot first is nothing but the destination node, and what is the weight of this edge is neighbor dot second. So I currently know from this node, from this p, I currently know u. So to reach at u in cost j, right? What do I know? I currently know u comma j. That means distance to reach at u in j steps. So why to go from 0? Because it will always increase step 1, right? One step. So this is v, and weight I know w. This is v, suppose v1, v2, v3. Weights I know. So from this I can directly calculate the cost to reach at v with j plus 1, right? V to j plus 1 will be, whether it is j plus 1 or only j, it depends on source. It is nothing but the cost to reach at u in steps j, in j steps, plus the weight, plus the weight 1, right? It is v1, yeah, v1 to j plus 1. Okay. So right. Okay, so we'll take this one only. Okay. So I write it. Yep. Okay. So I know j is the number of steps I currently know. From here we can write cost. If the cost to reach at v in j plus 1 steps, j plus 1, there is j plus 1 or it's only j. So if it was a source node, then j was 0. So then the intermediate node will have in 0 steps, but if it is an so I think I can write u is equal to source. So if it is intermediate node, u is not equal to source. So if it is an intermediate node, this condition will hold and we will have one steps. Okay. So if cost to reach at v in this is greater than the cost to reach from u to j plus the weight, this one, right? So cost from u plus w, if this cost is less than the current cost, that means we need to update the current cost. You can have the current cost, which is nothing but cost of v, and j plus u is not equal to source, so it will be the cost of u j plus w, and push it inside the set. st.insert is nothing but the distance and the source and the steps. So before that I would need this condition also for updating. What if set already has that? So what if we cannot insert in set, it directly has that. If st.find of is not equal to st.n, we need to st.image. dot find what this pair only, right? Because we are inserting this, so if it already exists, so the cost and the node and this, so if dot find of this already exist, then erase that and update the new pair. And finally, what will be my answer? Answer will be for the source node, go to all the need to minimize it. So answer is min of answer and cost to reach at the destination node in k steps. So we can just return answer is equal to infinite then minus 1, otherwise answer, right? If answer is infinite then minus 1, otherwise answer. Okay, so will it work? What is infinite? Okay, we will define that. So let's see if it works or not. So what is infinite? Cost infinite is equal to, what's the maximum price? 10 raised to 4 and n is 100, so 10 raised to 6. 10 raised to 6, anything greater than 10 raised to 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Find the cheapest price. Let's see. So we have defined the adjacency and we have the vector pair adjacency of n cities. Go to every flight in the flight and write directed is from to with this weight. Okay, so we have created the graph. Create the cost and put it inside the set. So vector of integer cost of n with vector of integer k with infinite. That means k and infinite. Okay, set of pair and cost to reach at source within 0 steps is 0. st dot insert 0 source 0. Apply Dijkstra from here. No, just dot insert. While set is not empty, remove that, and u will be p dot second dot first, p dot second dot second. Because p dot first is the cost, p dot second dot first is the node, and next one is the number of steps. So from here, go to the neighbor, which is a pair, find the v and what's the price, what's the cost from u to v is w. So if from v to any other node apart from source, then it will be +1, because if u is not source, if u is source, then what will happen? Then u is equal to source, then it will be 0. That means in no jumps I can go to v, in no stops I can go to v, so it will be z only, right? Yeah, so that will be cost of u to z plus w, obviously. So if that, but if it is not the source, this is intermediate, and this will be true and 1. So that means I'm not coming from source, that means I'm coming from a intermediate node. That means that intermediate node was already a stop. So that means for v it will be j plus 1, cost it is this, and updated vj u not equal to source will be this, and insert inside the cost vj plus u not equal to source. And if st dot find is u not equal to source, v plus j u not equal to source is not equal to end. Okay. Then finally I will have the distance I need to find at most k stops. That's why let's start with infinite and find the minimum of all these maximum k steps for the destination. What to return? I think this should work. Okay, there is compilation error. Place back. Vector of pair of adjacency of this dot push back the flight 1 flight 2. I think in place back works with make pair only, not this one. Flight 1 flight 2. Okay. Okay, I got the what might be the problem, because we already have deleted this. We cannot get this one. Okay. Okay, what's the error? Let's see. So while set is not empty, go to the neighbor, vu cost to this is greater than cost to this, and happens in reverse. Okay, answer is infinite. Okay, maximum k steps, so it should be k plus 1, right? And n is 0 based indexing. It's 4, so 0 to 1. Okay, it is 0 based indexing, but k can be k plus 1. Right. Oh, what the heap overflow. What could be wrong? Find the cheapest flight. Flights of 0, so it is from flight of 1, flight of 2. Push back. Now go to vector k plus 1, everything infinite, and go to source 0, insert 0 source while set is not empty. Get that st dot begin, erase st dot begin, st dot begin, st dot erase the st dot begin after getting that from P. Okay, go to the neighbor. Now the adjacency of u will be a vector of pairs, so v, u, v and w if cost st.erase, find the cost and the pair v and the steps and cost to reach first v j plus w. So w is the weight, current weight, plus must use a, this is this v and j plus this is to insert cost v. What's the destination and what's the k? So for all of them, find this. Why would it? So null pointer exception here. Okay, why? Am I erasing it? Yep. Buffer overflow. Begin. Let's see. Okay, something wrong with this code. But what's wrong? Okay, so what is B? So for first, what is B? Oops, divide. One, two, three, 0. So from here, from 0, you can go to 1. And from 1 to 2 to 3. From then 2 to 0 again. So in which order it is picking? U and J. should be 0 0 0 0, and then from 0 0 it goes to 1 0 with 100, 1 0, then from 1 0 it goes to 2 0, 2 1, from 2 1 it goes to this one, but why to go there? So 2 1, from 2 1 it goes to 2 1, it is throwing error. It's running infinitely. Count. Count and see out count. From 0 0 1 0, from 1 0 it is first one, from 2 0, from 2 1, from 1 0 it goes to 2 1. Once 2 1 is taken, it will go to again 0, 1 node, right? So cost to reach at 0 with j is nothing but 1, so 1 plus this, so 1 stop, 2 stop, so 1 plus 2, so cost of 0 comma 2 it is calculating, if it is greater than cost of 2 comma 1 plus 100, it is not the case. So for every neighbor, if this holds, u comma j, what is j initially? J is increasing by 1 only, j can be at max 1. So what is k? Oh, so why to keep k only? So I think, yeah, got it. So k it is index out of bound. So let's go to, either I can initialize it as 10 raised to 4, 10 raised to n is 100, and what is k? There will not be any multiple plate, so what will be the k? K is less than n. Okay, let's have this as n only, n plus 1, then it will work. Got got it. Still it is throwing runtime error. Okay. No, why? So k is less than n. Now what could be the case? Heap overflow and address this. Okay. So which node I'm taking? From here to here. Is it taking here? No. Somewhere here only. So 7 and 1,4. Let's not go if the gap is so cost. So how many steps will be required? Let's go only if j plus u is not equal to source. So this is less than or equal to k and this holds. Then only go. First, there is no point in going to greater than k, right? Yeah, in first go. Great. I think this was the why it will create the infinite loop, or it will go to multiple times to the same node. It can go till any square. So if there is a loop, what will happen? So it can, if there is a loop, it can go k plus 1, k plus 2, k plus 3. So it can go on till infinite. Yep, got it. So this thing will remove the infinite loop. Good question.